Good morning, everyone. We are about to start. Very briefly, my name is Estela Lopez Hermoso. I'm EU Project Manager at European Bioplastics and today's moderator of our Preserve training. Thank you very much for joining us today. For those of you who do not know the EU Horizon 2020 Preserve project, I will put the link to our project later in the chat. Thank you very much. We're getting people filling up the room. If you could keep yourself muted, that would be great. There will be time later for a Q&A. But thank you for joining us on this research training on biodegradation, one concept, many environments, which is provided today by our partners and experts from NORMEC, the OWS. We'll start in a minute. As you might have seen, we are recording this training. The recording will be then later available on our socials of the Preserve project and will be shared with you in due time. Before I pass the word to my colleagues, some housekeeping rules. As I said several times, for some people might already, please keep your microphone muted and your camera switched off. We will be taking questions afterwards. The training will end at 11. Before that, of course, there will be a time for a Q&A, and then you will be able to put questions forward, either unmuting yourself and putting your camera on or in the chat. With having said that, I'm still seeing people joining in. So I keep the housekeeping rules just for a minute more so that you can see them. And I'd like to introduce our experts today from NORMEC, OWS, Stephen Versichter, Division Manager, BCDE, Biodegradation, Composting, Disintegration, Environmental Safety, and Gael Cavalier, Technical Sales Engineer at NORMEC, OWS. And just a few words about why we're organizing this training. As I said, we're organizing it in the framework of the Horizon 2020 funded project Preserve. And why? Well, because in recent years, waste littering in the open environment has reached the level of a global emergency, as we all might know now. And this is due to the release of harmful substances from such waste streams, just plastic litter, for example. And of course, this has impact on soil, water, biodiversity, and lands, marine habitats, and so on. Therefore, the safe biodegradation of bio-based materials and products, according with the environmental conditions and time conditions and time frame for specific applications, is a priority for lawmakers at EU level, and therefore it's a priority for our societies. And there's a lot of expertise working on this field in Europe. And our colleagues here from NORMEC WS contribute to this very intensively. In Preserve, actually, concretely, we aim at substituting the linear use of plastics with a circular approach. And that's why we're doing this today. We want to substitute conventional fossil plastics by bio-based or recycled ones. And biodegradation as an end-of-life option is an important cornerstone for our focus. So I invite you all to look at our website, at the Preserve project, and to follow our socials for more information on the project and our results so far. I will leave my Stephen and Gael to the presentation of what NORMEC OWS is, because they are the people. So with that, I'll pass the floor to Gael and stop sharing my screen now. And I just wish you a very enjoyable training.
Yeah, can you hear me now? Okay.
Yes, we can. Yeah.
Okay. So we do today a training on biodegradation, and specifically biodegradation in many environments. Wait, I wanted this. Yeah. Okay. Was it not moving? Ah. No. Okay. So we will start with an introduction on lawmakers. Then we will see what are actually bioplastics, and then we'll dive into the subject of biodegradation and the associated standards and certification schemes, biodegradation in managed environments and also in unmanaged environments. And then Stephen will develop on the EU project's results. So Normico was created in 1984 as a spin-off of Ghent University, and the initial focus was on anaerobic digestion of biowaste. There was in 1990 first laboratory to develop biodegradability test, and in 2020 it was acquired by Normico the lab and consulting services became Normico AWS. So we are a one-stop laboratory for biodegradation, compostability testing, and ecotoxicity. We are strictly independent, so we don't make product, we don't sell products, so we remain neutral with our customers. And we are recognized by all certification bureaus working in the field. So BPI, TUV, DNCert Co, which is very advantageous. We have very large capacity of more than 3,500 reactors. We have very short lead times. Usually we start testing within 2 to 3 weeks after reception of your samples. So we do biodegradation, composting, disintegration, ecotoxicity tests, as well as consulting services. We have more than 35 years of experience in the field. Our headquarters is in Ghent, in Belgium. We also have an affiliate lab in Kettering, in Ohio. In total, it's more than 100 employees and a turnover more than 10 million euros. And we have clients, more than 1,500 clients in the world. We are also very active in standardization, certification, industrial associations, which give us a good overview of possible upcoming changing in certification and standardization. And we also are very active in European projects. So Stephen will develop all those projects later in the presentation. The markets we serve, so base polymers, paper and board, chemicals, including additives, inks, all sorts of adhesives, packaging, research and lab university, cosmetics, textiles, agriculture, and so on. Our 3 main departments, so the testing facility. We also do waste inspection and sustainability assessment for LCA, carbon footprint, EPD, environmental product declaration. We'll focus today on the testing laboratory, where we do biodegradation tests in compost, home and industrial, in soil, freshwater, seawater, and landfill anaerobic digestion. We also do consultancy services, and we do ecotoxicity tests on terrestrial, aquatic, and microbial organisms. So bioplastics, what is it? Does it mean biodegradable, compostable, biobased, or the 3 of them? So actually, bioplastics, they can either be biobased or biodegradable or both. Biobased is linked to the origin of the material. It comes from renewable resources versus fossil-based, petrol-based material. And biodegradability is related to the end of life of the material, to the chemical conversion of the organic carbon into carbon dioxide. So biobased does not necessarily mean biodegradable. Here you have, for example, BioP, BioPET, which are bio-based polymers, but they are non-biodegradable. Petrol-based does not necessarily mean non-biodegradable. You have here PBAT and PCl, which are fossil-based polymers, but they are biodegradable. And of course, you have bio-based and biodegradable polymers, which are also bioplastics. Here you have the logos of the DINSERTCO and the TUV on which provides certificates on the bio-based carbon content of your products. And that's it on the bioplastics. We will now dive into the biodegradation and what is it. So the biodegradation is the actual conversion of organic carbon in the presence of oxygen into CO2, water, humus, and biomass. And then plants, they consume the carbon dioxide and produce, do the photosynthesis, release oxygen. In the absence of oxygen, you have as well as carbon dioxide production of methane. So biodegradation, chemical process, conversion of the organic carbon in the presence of oxygen into CO2, water, and biomass. In the absence of oxygen, you have as well the production of methane. So there's general opinion that 100% of the organic carbon into a material should be converted into CO2, and we should yield 100% of biodegradation. But actually, some of the carbon in the organic carbon here is actually used for biomass growth. Here you don't yield 100% of conversion, and that's why the pass levels of the certification schemes and the standard is set at 90% organic carbon conversion. And this leaves room for the biomass growth. There is some standards, for example, certification with BPI according to ASTM 6400, which requires ingredients present between 1 and 10% to be tested separately for biodegradation. And this is to avoid, for example, companies to reach 90% biodegradation, but then to have 6 or 7% of non-biodegradable polymers, which could potentially then lead to microplastics. This rule of components present between 1 and 10% to be tested separately for biodegradation is not yet present in Europe in EN 13432, but will potentially be included in the revision, very likely be implemented. So what biodegradation is not? It's not a physical process, it's not disintegration, fragmentation, molecular weight reduction, loss of technical characteristics, diminishing in particle size. So it's not all this, it's just the biochemical conversion of organic carbon into CO2 and methane in the absence of oxygen. Biodegradation can happen in various environments. It can happen in compost, so home or industrial, in freshwater, in seawater, in soil, and in anaerobic environments like landfill or anaerobic digesters. The aggressiveness of the environment can vary. So the biodegradation varies as well from one environment to another. There is no extrapolation possible. The most aggressive environment is industrial compost, which has the higher temperature, where you can find fungi, bacteria, and actinomycetes. In home compost is the next more aggressive. You also have all these microorganisms, but the temperature is a bit lower. And in soil, again, that's the next more aggressive. You have a lower temperature, and you still have those microorganisms, but the inoculum is less active in soil. Where in compost, you have all the organic matter, you have frequent aeration as well. In freshwater and marine water, you only have bacteria and some filamentous fungi. And in anaerobic digestion, you only have multiple bacteria. So some material and some polymer like PBAT, lignin, keratin, chitin, who needs the fungi to degrade, they won't do well under anaerobic digestion. It's very important to always specify the environment where a material is biodegradable. We see a lot of claims on products that says biodegradable, just biodegradable, and this does not necessarily mean anything. It's very important to specify in which environments is biodegradable. It could be biodegradable in soil, doesn't mean it will be biodegradable in marine water, and so on. So important to specify the environment. This is so the main polymers, biodegradable polymers on the market, and the environment in which they can biodegrade. PBSA has now been tested as well in freshwater and marine conditions. And PCL is actually now been tested in all a lot more environments, and is biodegradable in all environments that are present here. This is an example of different polymers and how they can biodegrade into industrial compost or soil. You can see that some polymers will go very quickly, some will have a lag phase and reach different level of biodegradation. In soil, you have the same. And in soil, for example, you can see that PLA and PBS don't biodegrade at all. So we will start now to focus specifically on biodegradation in controlled environments, and we'll start with compost. Composting versus biodegradation. So there is also nowadays those two terms are a little bit misused and interchanged in the same way. But actually, biodegradation is only one component of composting. So composting includes 4 parameters: material characterization, ecotoxicity, biodegradation, and disintegration. So we will see in more details what are those 4 aspects. So material characterization. So this is the chemical analysis of the material, and is to check the heavy metals and the fluorine content of the test item. There are some specific limits set by the different standards on the heavy metals and the fluorine content as well, and you should not exceed those limits if you want to certify according to those standards. Heavy metals, usually if you exceed those limits, it's usually due to inks in the sample. Ecotoxicity, so what is it? So the test is to evaluate the potential toxic effect of residuals left after the composting. It's to prevent potential toxic residue, to inhibit plant growth, or diminish the survival of earthworms. Plant toxicity is part of all the standards for industrial and home compostability. It prescribes the use of 2 plant species according to OECD 208, and the earthworm toxicity test is only required for certification in Australia, for home and industrial in Australia, according to OECD 207. This is an example of a graph that you can obtain after a plant toxicity test. So we compare the germination rate and the dry weight of the plants which have grown on a compost in which the test item was added versus a blank compost. There should be less than 10% difference in germination rate and dry weight of the plants which have grown on the test compost versus the plants which have grown on the blank compost. Same principle for the earthworm. We compare the survival rate and the average weight of the worms from the test compost versus a blank compost, and there should be less than 10% difference between the test compost and the blank compost. Disintegration. So the disintegration is influenced by the shape, the thickness, the grammage, any coating print. So it's related to the physical aspects of the sample. So we added as such to the compost. We follow the following method, so ISO 16929, which is the standard for determining the degree of disintegration under composting conditions in a pilot scale test. So here in Untitled, we use 200 liter reactors, which we divide in 2 compartments. And for home, the prescribed standard is IO 2200. The pass levels are 90% in weight must go through a 2 mm sieve after a maximum of 12 weeks for industrial composting and maximum of 26 weeks for home composting. So it should have completely disintegrated into a fine powder of 2 millimeter. This is just an example of some pictures that we will take during the disintegration test to show how the sample is fragmenting. And finally, the biodegradation. So for the biodegradation test, we mail the sample. So mailing the sample won't have any effect on the final level of biodegradation you will achieve. It only speeds up the process because it increases the surface area of the microorganisms to your test item. We add it to a mature compost, which is the inoculum. The temperature is 58 degrees for industrial composting, 28 degrees for home composting. At the start of the test, we measure the total organic carbon in the sample, and then we measure the conversion into CO2. So the CO2 is trapped into potassium hydroxide solution, and then we do a titration to determine the amount of CO2 released. We monitor the CO2 production in the test compost, a reference compost cellulose. This is to check that the inoculum is working properly, and the blank compost, this is to determine the background activity of the inoculum. The pass level is 90% in 6 months maximum for industrial composting, and maximum 12 months for home composting. So to summarize, for industrial and for home compostability, so you need the 4 criteria: chemical characteristics, biodegradation at 58 degrees, and the pass criteria is 90% within 6 months for industrial, performed at 28 degrees for home composting, and the pass criteria is 90% within 1 year for home composting. Disintegration in industrial compost, 90% must be reached within 12 weeks. And in home composting, 90% must be reached within 26 weeks maximum. Ecotoxicity for both environment as well, either on plants or if you're certifying, for example, for in Australia on earthworms as well. The toxicity test on earthworms will also very likely be implemented in the revision of EN 13032 as well. There are also, so there's ways of optimizing the testing as well. For example, if you want to certify products for home composting and industrial composting, you don't necessarily have to perform 8 tests. On chemical characteristics, you do it once, same as ecotoxicity, and the biodegradation under home composting condition, because it's performed at 28 degrees, which is stricter condition than 58. Certification agency accepts this test performed at 28 to cover as well this test. So there are ways of optimizing the testing program. So those are different logos for composting. So we look first at the industrial composting, and the certification agencies associated to them. So you have the OK Compost from TÜV Austria, the DING approved from Dinserco, the Seedling from European Bioplastics, BPI Compostable, and the one from ABA. So those certification schemes, they are based on standards, ISO ASTM D6400 or EN 13432, which are the theory, the basis of the certification scheme, and then the certification scheme, they are the control system. They are based on standards, and they add as well their own, they have their own additions to this. So we look first at the standards for industrial composting. So you have 2 ISO standards on plastics and packaging, 2 EN standards for plastics and packaging as well. So the very well-known EN 13432 in Europe, 3 ASTM standards on plastics and paper. ASTM D6400 is the basis, is the standard on which the BPI certification is based on. And AS4736 for Australia, and that's the basis of the certification scheme with ABA in Australia. So there's a distinction between those standards, which specify the criteria that have to be evaluated, as well as the pass levels. versus the test methodology, which I will present in a few slides, which specify the test conditions and the measurement methods. So let's have a look now at the different certification scheme, and we'll first, during this presentation, look at the certification scheme in Europe. So those three certification schemes, they are all based on EN 13432, which is the standard for packaging recoverable through composting and biodegradation. So as I said, 3 certification scheme, OK Compost Industrial, Seedling, DING approved, all based on EN 13432. With for DING approved, there's actually also the possibility to certify according to other standards, so EN 14995, ISO 17088, and others in parallel, but the basis remain EN 13432. So as I explained before, for composting, 4 criteria are needed: characterization, biodegradation, disintegration, and ecotoxicity. Here you have the different test methodologies that are specified, and you have for each criteria some specific pass level that need to be met. On heavy metals, fluorine, volatile solids, and biodegradation. So for industrial composting, as 90% within 6 months. Disintegration 90% within 12 weeks, and ecotoxicity on plant 90%, germination on the biomass. And of course, if you for DINSOTCO, if you want to certify according to the Australian standard, which is possible, you also need to add then toxicity on earthworms. And this is the logos for home composting certifications. So there are currently 3 available on the market. So the TUV OK Compost Home, the Home Compostable Certificate from DINSOTCO, and the ABA one for Australia. And BPI is developing one for the US, as well as developing an ASTM standard as well for home composting. It's expecting, not the ASTM that won't be ready in 2024, but the certification scheme is expected by the end of this year. So the different standards on which the certification are based on. So the French standard for plastics, that's the basis for the OK Compost Home from TUV Austria. Then you have EN standard for packaging and 17427, and the ACE 5810 for Australia, which is the basis for the certification scheme in Australia. There are some differences between the 3 standards, which are outlined here. So again, for composting, always 4 parameters are required: characterization, biodegradation, disintegration, and toxicity, all required for the 3 standards. The variation in those standards lie in the test method for the disintegration. So the Australian and the French one are based on ISO 2200, and the European one for packaging prescribes the new standard EN 17428 for the disintegration test. There's also differences in toxicity tests. Only plant is required for the French standard, plant and earthworm for Australia, plant, earthworm, and microorganisms for the EN 17427 in Europe for packaging. So this will close the section on biodegradation in composting. And what are the benefits of composting? So it diverts biowaste from landfill, so it reduces methane emission. So just as a fact, if food was a country, it would be the 3rd largest greenhouse gas emitter in the world. And in the US, is the 3rd largest source of human-caused methane. The packaging and packaging waste regulation recognizes also the benefit of composting for some material when there's a higher biowaste capture, and it also a lower contamination of compost by non-biodegradable plastics. Incineration is not ideal for biowaste, which have a relatively high moisture content, so it's not efficient to incinerate those biowaste. compostable plastics products, they increase the carbon level in the compost. So usually composts are rich in nitrogen. So adding compostable items in the compost balances the ratio carbon to nitrogen. And compostable items as well are great for hard to recycle products like laminates, small formats, tea and coffee capsules, which not only are very small, but they also have organic matter in them, which should be added to a compost and not sent to landfill or incineration. So we will carry on with biodegradation still in controlled environments, and we look at anaerobic environments. So the objective of composting obviously is to produce high quality compost. In anaerobic digestion, there's a dual objective, so production of biogas and production of digestate. Oh no, missing some slide. Okay. Biodegradation in uncontrolled environments, in freshwater, in soil, and in marine water. So the open environments can cover products that are added intentionally in those environments, like controlled release fertilizer, mulch film, tree guards, fishing nets, flower pots, and so on. Or products that end up accidentally in those environments, like balloons, tires, shoe soles, clothes fibers, etc. Here you have, so a bit overwhelming of a table, but we will look into details of some of those certification schemes. So for soil, you have different logos here for the soil certificates, freshwater and marine water. There are 3 certificates currently available for soil biodegradation. One provided by TUV Austria, one by DINSOTCO, and one by ABA. There's only one freshwater certificate, and it's provided by TUV Austria, and 3 for marine water biodegradation. One provided by TUV Austria and 2 by DINSOTCO. So obviously, the goal is not to certify any items. The goal is not to promote littering by certifying item and saying that they're okay biodegradable in soil or in freshwater or in marine water. So while it might be possible to certify any items, getting the logo and advertising to customers is a different story. So depending on the end applications of your products, you might not be able to get the logo and advertise it to your clients. So this is something that you can possibly, for example, packaging. We don't want packaging to end up in fields or in the sea. So advertising soil or marine biodegradability on the packaging is something that you can possibly do in B2B, business to business, but not to customers, not to encourage littering. Here you have the different standards that are prescribed for the biodegradation tests. The one with the stars, so those 2 ones are actually standard that specifies different parameters, not only the biodegradation, but other parameters. And here you have the past criteria. So for soil, on biodegradation, 90% must be reached within 2 years. For freshwater, 90% must be reached within 56 days. And for marine water, 90% must be reached within 6 months for the certification with TUV Austria, within 24 months for certification with DINSOTCO. So there are some differences as well in the certification schemes here. We are going to look for the soil, specifically at the N 17033, which is the standard for the biodegradability of mulch film. So this standard specifies 3 criteria for the certification of mulch films. So biodegradation. So again, 90% must be reached within 24 months. Temperature is approximately 25 degrees. chemical characteristics on heavy metals and volatile solids, and then ecotoxicity. These standards prescribes to test plants, earthworms, and microorganisms. And for the certification with TOV Austria on OK biodegradable water, two parameters are requested to be tested. So biodegradation, 90% must be reached within 56 days at 21 degrees, and chemical characteristics on heavy metals and volatile solids. It's also possible to optionally test the solubility and the dispersibility of the test items for items that are suitable to be disposed of in wastewater treatment plant. And this test is performed according to EN 1414987. And this is not mandatory in the scheme. For biodegradation into marine water, so let's have a look at the three and compare the three different certification schemes. So they all require 4 parameters to be tested: the biodegradation, the chemical characteristics, the disintegration, and the ecotoxicity. The biodegradation for TUV Austria certification is performed according to ASTM 6691, and 90% must be reached within 6 months. For certification with DIN-CERT-CO, the biodegradation can be performed according to ISO 22443, and I will come back to this later, because this ISO standard actually lists several options for the biodegradation. And 90% again must be reached within maximum 2 years. Chemical characteristics, so heavy metals and volatile solids for all the 3 certificates. Disintegration as well. 90% within 12 weeks for certification with TUV Austria, within 6 months for DIN-CERT-CO. And there's actually, DIN-CERT-CO also offers a DIN Plus certification, in which it differs in the disintegration test, where disintegration in real life conditions, so in the sea, is needed within maximum 3 years. So the sample is placed into a crate that actually goes into the sea, and then the disintegration is recorded. You just lift the crate out of the sea and you look how the disintegration is happening. And this is only part of the DIN Plus certification. And the ecotoxicity for certification with TUV is only required according to this standard, and is only performed on Daphnia organisms. For certification with DIN-CERT-CO, the ecotoxicity is performed according to ISO 5430. And this actually specifies different level that needs to be tested. That will explain now. So primary producer algae needs to be tested as part of this scheme, as well as primary consumer invertebrates and decomposer microorganisms. So, and here you have the different test method on the base level. So for certification with DIN-CERT-CO, it's a little bit stricter. There's more organisms to test than with TUV, where you only have an ecotoxicity test on Daphnia. And that's the one I wanted to come back on. So for certification with DIN-CERT-CO and the biodegradation test, you can test according to ISO 22403, which actually mentions various environments. So for final products or each individual constituents, 90% biodegradation must be reached either in seawater or in seawater sediment interface or in sediment. For the organic constituents in your sample that are present between 1 and 15%, readily biodegradable tests according to in freshwater, according to OECD 301, 310, is also an option. And that will close the section on biodegradation. And I will leave the floor to Stephen.
Okay, thank you, Gael. You could show the slides. Keep on showing them because
Yeah, so let me know when I
it's easier. Yeah, so biodegradation is also recognized in Europe much more, also in European projects. And in the next slides, I will just give you some examples on projects we were involved. So you can just go to the next one. The first one is on preserve, which is also this training is located within this European project. So the ambition, as mentioned also by Estelle, is to make high-performance sustainable bio-based packaging, so from biological resources, which has a tail end of life. That's not only biodegradation or organic recycling, which is then a circular approach. If your material is made of natural materials, you start from the nature and you go back to the nature. But it can also be just mechanical recycling and even upcycling of your materials to high valuable products. This is what we try to do in the project. We have two products that has been developed so far. One is a whey protein coating developed by the Hogeschool Amsterdam-Sigmaringen, which has improved oxygen barrier properties. We demonstrated that this material, this coating, is biodegradable under industrial composting conditions. This is the green line on the graph, which was even higher than the reference material cellulose. So it's really degrading quite well. And also in marine conditions, the degradation is quite fast. So products can for sure be biodegradable under industrial composting conditions and marine conditions at the same time. We also followed this coating. It was applied on a PLA film with a thickness of 0.5 millimeter. And we observed then complete disintegration that can be seen in the slide frames, which were added during the composting process. So after 4 weeks, everything was disappeared. So you can see that this material is quite good degradable and also has a possibility for industrial composting. Next slide is a pH-coated paperboard that was developed by Centexbel. The pH coating ensured that there was less water absorption. So we tried this on a paperboard with a thickness of 0.5 millimeter and a grammage of 360 grams per square meter. The slides below show that these materials are degrading quite well without the coating in industrial composting conditions. This is seen in the left. So as mentioned by Gael, this is the maximum duration is 12 weeks for this trial, but after 10 weeks, almost all slide frames are empty. And for home composting, you can see that this is the trial to the right. So there you have a time duration of 26 weeks with lower temperature of 28 degrees. And also there, the process went very well. So the pHA is potentially to be used for home compostal and industrial applications. In the next slide, we have another project, which is Bio on top. This project has been finished, and there the ambition was to produce novel films, packaging, and textiles that were bio-based also and biodegradable at mild conditions. But the purpose was to start with PLA. And the reason for that is because it's bio-based, it's biodegradable, it's also the most affordable bioplastic so far and has already a high production capacity. But there's one drawback of this material. It normally needs a thermal trigger before the biodegradation starts. So PLA is degradable, but only when you reach high temperatures, such as in industrial composting or in thermophilic anaerobic digestion conditions. Still, we were able, we did several attempts to make PLA more degradable, and one of them that was most successful is with blending by the PLA with PCL or PBSA, which are other bioplastics commonly used. And we see in the graphs here the trials that were performed under home composting conditions, so at 28 degrees. The graph on the left, you see blends of PLA and PCL. So the blue line is the cellulose, which is our reference material, it's valid test. But you can see when by increasing the amount of PCL, the degradation proceeded much faster. If we added only 5% PCL, the lag phase was about 120 days. And by increasing then the PCL content, we really could shorten this lag phase. This was a very interesting result because it also allows you to tune the biodegradation. So some materials should degrade faster than other ones. So that's an interesting point we observed in this project. And the same effect was seen not only for PCL, but also with PBSA. If you combine it with PBSA, with increased biodegradation risk. And I see I rose the question in the chat. We also blended it with PHA. PLA, but that had not any effect on an increased degradation under home compost conditions. In fact, no signal on degradation was seen. In both graphs, you see the purple line in the back, which was pure PLA, and it was not degrading at all. So that's an interesting result. Indeed, you can go to the next one. This is another European product, Sea Life, which is currently finished by the end of this month and brings advanced bio-based product solution to the market. We followed applications that can be used in land, such as rigid and flexible film packaging, and also for agricultural applications, which we show in the next slide. But also there were deep frozen films for fish were produced, fish crates, oyster mice bags, and fishing nets. The purpose was to make them bio-based, but also to make them degradable in different environments. In this project, there was also an important part on policy and standardization. So we were in contact with the European Commission to show results. And we developed further on the marine toxicity test for biopolymers, as also mentioned before by Gail. And this project, we also introduced 5 new worker item proposals for standards in the field of degradation, and it's mainly in the field of anaerobic degradation because there are no clear standards are existing yet. And then we did some interesting trials on marine degradation. We compared the lab testing with the field testing. So we had samples in the sea of the Gulf of the Bay of Biscay and also in the Mediterranean Sea. We are now collecting all this data, but we already observed that the procedure by ISO 23832 was even much less sensitive compared to the real life. This you can see in the table at the right. The several materials we applied there, and after 6 months, we, according to the ISO standard, we did not see any degradation. So the films were still quite intact, while in real life, these are really degrading fast. This is also seen in another lab procedure based on the TÜV certificate, where it was a quite similar approach. So it's really good to look at the different standards and to try to simulate also what is in the environment. The next slide is an example of a material we have developed in the project. This was a mulch film, for which the goal was to make it industrial compostable and soil biodegradable. The first results show the results on industrial composting. So left you see the graph on biodegradation, which was very well and quite fast. And then the picture on the right, you see that how the disintegration was proceeding in the pilot scale composting test according to ISO 16929. So after 3 weeks, the material was completely disappeared. A partner of us also checked the biodegradation on different soils and in different temperatures. These are 2 graphs on the left. So when at a lower temperature, this degradation goes lower, but it's good that degradation is not always that fast in mulching because you have to fulfill your application. The degradation should be linked with your growth season, and that's important to follow. And that's also why we tested the degradation at different temperatures, 50 degrees and 25 degrees Celsius, to follow up and to see what will be the impact in reality. The next slide is another project we are running now, which is mainly to release the potential of feathers in a more circular economy, and especially for agriculture applications. So the feathers, they contain a high amount of keratin, and these materials that will be developed in the project should be zero waste, have a controlled biodegradation, and also enrich soils with organic nitrogen, which is present in the keratin. You can see in the graph on the right that the yellow line shows the treated feathers, that they have an improved biodegradation compared to the raw feathers. So that will have a biodegradation for the products. We wanted to produce mulch film, hydroponic foams, non-woven textiles, and forest and seed trays, which all should degrade in soil and also under some application in the compost condition. But the degradation should be adjusted according to the lifespan these materials have to fulfill. And then the next project is a champion project. This is a more complex project. Here we want to adjust currently based polymers that are used like for adhesive coating detergents, and often based on petroleum-based, and have quite some toxicity issue during production, and are not recyclable or biodegradable. We want to develop a new range of polymers based on the azamycyl chemistry, which are bio-based, which also the production phase is much more environmental safety and all should be circular by design and biodegradable. And the next slide, you can see that we tried this biodegradation testing. So we were responsible for that fact. The conventional products so far are having limited biodegradation, but we observed also that when we functionalize our pre-polymers with amines, the biodegradation decreased. So that was not what we hoped for and anticipated, but solutions are found within the project to solve this. But interesting to see that normally these materials are cured by a conventional radical cross-linking, and there you see the green line in the graph that there's no degradation occurring. That's the line on the bottom of the picture. But when we do a cross-linked with the azamycyl chemistry, we could see that there is in the red line that there's really an increase in biodegradation potential, and that's we can finally find compounds that are biodegradable in an environment. Here we tested in an accelerated soil biodegradation test at 37 degrees. And the last project I shortly want to introduce, which we are involved, is the MyFair project, where we want to provide to the textile industry a new non-woven fabric, which is made of mycelium fibers. And they should also have a very high performances and then a reduced environmental impact in comparison with our commercial available fibers. So we have several environmental objectives in this project to reduce the use of chemicals and natural resources, to make a product that's bio-based, so that has a low carbon footprint, also be circular by using residues from other value chains and try to close a loop where also biodegradation and compostability plays a role. So if you have bio-based material, it's biologically degraded and it goes back to the nature and can be used then for yielding new plants. We try to have we investigate biodegradation. That worked quite well on the raw materials, so the raw materials are getting well. But if you want to have high performance materials like that are used in fashion or in automotive industry, you have to do quite some large pre-treatments, just the same as with leather, and they really have an impact on biodegradation. So we need to work further on it to improve the biodegradation. This was all from my side. You can see our contact details. We're always interesting if you want to contact us, for sure, Gail, who is our salesperson. And then we give the word back to Estelle of European Bioplastics, for which we thank you for this opportunity.
Thank you very much to you, Stephen Gael. It was a wonderful presentation. I think we all learned so much about the basics, the not so much basics, so the really in-depth, what is all behind the whole standards and certifications and therefore the labels afterwards. And then we saw all the results in all these projects and so much that it's been done and so much potential to actually solve many of the issues that we have right now, as I mentioned, in our environment. So we have had already some questions that Stephen so diligently already answered in the chat, but we still have a couple more questions already in the chat. So I open now the floor. I think that if you'd like to just unmute yourself, raise your hand, unmute yourself, that will be great. Otherwise, I can read the questions if you wish, and we get with it. I don't see anyone going for it, so I can read already one question. There is here from Siga. How safe are the biodegradable solutions for food contact or hygiene products? Have you done any projects or tests for flexible packaging in food sensitive products?
Yes, that has been discussed as otherwise. We also have to check, like with conventional products, if they are food safe, and it's mainly done by migration testing. So we see that there's no product from the coating or from the human product is getting into the food. So that's typically done by migration testing in different environments, and that's how they check the food safety. So we have done it for several products, and we had so far no real issues on these things. So quite safe.
Thank you, Stephen. Since I don't see any hands, if you allow, I then keep on reading questions. Here we have another one from Alalim. I don't know if that's the name or the username. Standard 13432 will have a new version. What do you think will be the biggest change? Any of you?
I would probably say so the inclusion of the earthworm toxicity test and the ingredients present between 1 to 10% to be tested separately for biodegradation. And potentially as well some inclusion on anaerobic digestion as well. So combination of composting and anaerobic digestion.
But it's a long process, so it takes more than a few years. So we hope that it's getting there soon.
Thank you very much. Yeah, it's a long process. I've been hearing about the revision of this standard forever. So yeah, but that's it has to be well done, right? I mean, that's the whole point. Another question: how are there from Skylan? I hope I'm saying this correctly. Are there any mandatory legal requirements that the product should be biodegradable?
So, I mean, I guess it depends if you want to just test the biodegradability of a product or test according to a certification scheme, get a certificate. But legal requirements, I don't think there are, but there is going to be the Green Claims Directive that is coming into effect probably this year, and the claims will be regulated. So I think this will then be at a state level to check if the claims are correct. So if you claim the biodegradability of something that is actually not biodegradable, I guess there will be consequences once the Green Claims Directive comes into effect.
Thanks, Gael. Yeah, there is a lot of things that are moving on at EU level, but as far as it concerns to a mandatory a mandate for products to be biodegradable, not. It's true that the Commission published a communication on compostable, also on bio-based, degradable and compostable plastics, but it's looking carefully into this and not yet putting more onto the table on mandates on this. More questions.
It's depending on the packaging and packaging waste regulation. They demand really that fruit stickers and tea bags and coffee bags with a filter are industrial compostable, so there is demanded, and they look for other opportunities. So it's getting more and more hot topic.
Thank you, Sven. Yeah, and more questions here we have from Falash Pancho. Hi, can you give further overview on the nitrification inhibition testing? Can you give examples if you had this project before?
You mean just as it's a kind of ecotoxicity trial, sometimes nitrification inhibition testing, but it's you add some ammonia, you check if they are the bacteria are degrading it, and it's only a process of 6 to 8 hours. But it may be easier to discuss this one by one if you send us this question, and it's easier then for everyone. But we have done these trials before in our lab.
If someone, we will remind you again that if someone wants to then contact Gael or Stephen and you have any doubts, I think that they as they said, they have their email addresses, and you could contact them if you if you wish. We have more questions. I think we have really just 1 minute, so I go to the next one. Sorry if some will be left out. In regards to PHA extraction from biomass, biomass can also contain protein apart from PHA. Have you worked on any project based on sequential extraction of protein and PHA and tried to use protein as polymer? That I think is a bit...
It's a difficult question.
Yeah.
I think there are fields of working on that. we have been also in a project like Cafipla, where they converted organic material also into biomass partly, and felt that fatty acids, which they also used part for PHA production. And another part of the biomass was then also with proteins. But I don't know the details, but that's an interesting concept. And yeah, we should try to valorize as much as possible from these streams. And maybe it would be interesting for a new European project. Follow the calls, and then it can be something interesting to investigate.
Thank you, Stephen. I'm afraid that we've reached the end of our webinar. There's still some questions here in the chat. I don't know if perhaps we have a look, and if we can answer them quickly in the chat, that will be maybe a quick solution. Otherwise, I think we will really run much later in the webinar. So thank you very much. I see there is a lot of interest. There is a lot of questions, a lot of answers, and thank you very much again, Gael and Stephen, because this is such a crucial topic. This is such a crucial craft that you do, that somehow holds the key for a sustainable future for all of us. It's a pleasure to work with you and EU projects and in general. And thank you very much for having the time to be here. As I said at the beginning, this has been recorded. We will have the presentation and this recording at the Preserve website, and then you have the contacts as well to contact us at the project and to follow us, and we can maybe have more exchanges. So thank you very much for everyone tuning in. And I wish you a good continuation of the weekend. I would start of the weekend, everyone. Thank you very much.
Thank you.
Estelle. Thank you, everybody, for following.
Thank you all.
If you guys want to look at those questions and answer them, great. If you have time, otherwise, I don't know if people are still waiting here.
Can we, if you click on can we answer directly? Or
I think so. Yes, I think so. You can click directly. Yeah.
Copy your code. But yeah, I have another meeting within 10 minutes.
Okay, then
but I tried.
Yeah, no, Stephen, then go ahead. I think that they will have the presentation, and they can always contact us for further follow-up questions. So please take care.
Yeah, I need to jump in another meeting.
Yeah. Thank you very much. Thank you very much again.
Thank you.
It was great. It was a really great presentation.
Thanks for hosting.
Thank you very much. We're in contact. Have a nice weekend.
You
Bye.
too.
Bye.
Bye.